All right, next we're going to talk about some examples, more examples for inverse functions. So the first one we have is f of x equals x minus 3 over x plus 2. I'm going to take the f of x and turn it into y notation instead. And in order to find the inverse, I'm going to follow my two-step process, which is switch x and y. So my y became an x, my x's became y's, and then my second step is to solve for y. So I'm going to go through the steps to get y alone. First thing I'm going to do is multiply by y plus 2 on both sides. So I have y plus 2 times x equals y minus 3. Next step I'm going to do is distribute the x. The next thing I'm going to do to solve for y is try to get these two y terms that I have on the same side. So I'm going to subtract y to over here. So I'd have xy minus y if I subtract this y over. I also want to get the 2x out of there because I'm trying to solve for y, so I don't want that there. So I'm going to subtract the 2x to this side. I'm trying to solve for y, so I'm going to factor out the greatest common factor, which is y. And then to get y alone, I'll divide both sides by x minus 1. And that is my inverse. Last thing we're going to do when we talk about inverses is talk about verifying inverses. And verifying inverses says if you have a number, you plug it into the one function, take that number, plug it into the other function, that it would pop out the same number. So doing that for one number is not enough, but I'm going to show you how it would work for one number. So if you do it for one number, if you pick like a 3, for example, if you plug a 3 in here, you end up getting 0. If you take that number and you want to change it back into 3, all you have to do is plug it into the inverse. Negative 3 times 0 plus 6 over 2 is 3. So if you run a number through the function, run that result through the inverse, it goes right back to the original. Verifying, though, does not mean just with one number, it means all numbers. So I'm going to choose x to represent all numbers. So that means I'm going to plug x in for x into this first function, and this is my result. Now I'm going to take that result and plug that whole thing in for x in the g function. So in the last one, all I had to do was plug in 0. This one I have to plug that whole thing in. And so here I'm going to just start simplifying and see what happens. So I'll distribute the negative 3. That becomes positive 2x minus 6 plus 6 over 2. My 6's cancel out. And then my 2's cancel out. So I started with x, plugged it in and got this, took that result, plugged that into the other function, and then it went right back to x because that's what I started with. That is half of a verification. The other half is to go backwards. Start by plugging it into g of x. And now take that and plug it in for x in the f function. So I took my result, which was this, plugged it in for x in the f function. I'm going to simplify and see if out pops x again. So my 2's cancel. I'm going to distribute a negative 1/3 here. Oop, that would be a minus 2, sorry. And then my 2's cancel, and it is x. So that would be all the work you'd need to do to verify.